Hello everyone. Today, welcome to this new lecture series where we will be discussing GATE 2024 lectures. In this, we will be discussing the previous year questions that is of GATE 2024, or this would be important for all of you preparing for the further GATE or so please, just we are starting with the textile chemistry portion. So just let's introduce what would be our strategies for these coming GATE 2024 lecture series. So we will be starting with the textile chemistry one. We will cover all these textile chemistry questions, and then we will move forward in a section wise manner. So it would be a beneficial for all of you preparing for this year GATE or the upcoming GATE examination. So starting with the very first question. It says that among us the following, the chemical used for bleaching of cotton fabric in acidic medium is. So bleaching of cotton, why it is done, or what are the different things that needs to be done in this aspect, or you should know for all these formulations what is the function of bleaching, or how these bleaching is done effectively. So if we start with the bleaching concept, so bleaching is done for the whiteness of the cotton fabrics, and the chemical that is used for the bleaching of the cotton fabric in the acidic medium means H ions so, should be present in the acidic medium. And if we say about the basic medium, so OH minus ions are present. So for acidic medium, different compounds are used for cotton bleaching is to make it more white, and to remove all these other impurities. So what is for bleaching in acidic medium, it is very direct. It is option number A, NaClO2. This you must have already read. So just starting with this next question, it says that in a discharge printing process, what it says, in discharge printing process, two dyes of different colors with one dischargeability HD and another with low dischargeability. एक की डिस्चार्जेबिलिटी आपको ज्यादा दी हुई है और दूसरे की डिस्चार्जेबिलिटी कम दी हुई है, एज वी कैन सी. सो इस क्वेश्चन में ये कह रहे हैं कि एक डिस्चार्ज प्रिंटिंग प्रोसेस में दो डाइस को लिया गया है, जिसमें कि एक की डिस्चार्जेबिलिटी ज्यादा है और दूसरे की डिस्चार्जेबिलिटी कम है. द करेक्ट स्टेटमेंट रिगार्डिंग द सिलेक्शन ऑफ द डाइज इज LD can be used as illuminant color, but HD cannot be used either as ground or as illuminant color. Second option is HD can be used as ground color, but LD cannot be used either as a ground or as a illuminant color. Or third one says that LD can be used as a ground color and HD can be used as a illuminant color. Or the fourth one says that HD can be used as ground color and LD can be used only as a illuminant color. तो देखिए, इस प्रोसेस में आपको ये पता होना चाहिए सबसे पहले तो डिस्चार्ज प्रिंटिंग प्रोसेस के ये गेट में इसी तरीके से क्वेश्चन दिए जाते हैं, सो एज टू कंफ्यूज एवरीवन. देखो, आपने इसमें दो टर्मिनोलॉजी को इस तरीके से ज्यादा कंफ्यूजिंग बना दिया गया है कि अगर आपको आता भी होगा तो भी आप इसमें कंफ्यूज हो जाओगे और इस चीज को गलत कर दोगे. और ये चीज अब गेट में सिंगल करेक्ट और मल्टीपल करेक्ट में इस तरीके के बहुत सारे क्वेश्चंस देखने को मिल रहे होते हैं. तो अगर आप ये देखो, डिस्चार्ज प्रिंटिंग प्रोसेस की अगर बात आप करोगे, तो बेसिकली डिस्चार्ज प्रिंटिंग प्रोसेस में एक डिस्चार्जेबिलिटी ज्यादा है. डिस्चार्ज में मतलब आपका पूरा कलर निकल जाएगा. और ये जो डिस्चार्ज प्रिंटिंग प्रोसेस में अगर जो आप डाई यूज करते हो, एक आपने पढ़ा होगा, तो ये डिस्पर्स डाई में आप ट्रांसफर प्रिंटिंग प्रोसेस में अगर आप बात करते हो, जैसे पॉलिस्टर पे आप करते हो, सो इस तरीके के प्रिंटिंग प्रोसेसेस आप करते हो, तो इसमें दो चीजें होती हैं. एक की डिस्चार्जेबिलिटी ज्यादा है, उसका मतलब क्या है, दैट इट वुड बी हाईली डिस्चार्ज, एंड द वन विद द लो डिस्चार्जेबिलिटी, उसका कलर कम निकल पाएगा. सो इसमें देखो, इसमें दो चीजें होती हैं. इट इज जो जिसका भी डिस्चार्जेबिलिटी ज्यादा होता है, उसको हम लोग हमेशा ग्राउंड कलर की तरह यूज करते हैं. क्यों? क्योंकि बिकॉज जब भी ड्राइंग प्रोसेस, जब भी आपकी प्रिंटिंग प्रोसेस हो रही होती है, तो द वन इन द ग्राउंड कलर हैव शुड हैव हाई डिस्चार्जेबिलिटी, बिकॉज इट विल इफेक्टिवली बी डिस्चार्ज ड्यूरिंग द प्रिंटिंग प्रोसेस। सो उससे होगा क्या, तो आपका जो क्लियर क्रिएशन होगा कलर का वो भी अच्छा होगा, और उससे वाइब्रेंट प्रिंट आएगा फैब्रिक पर। तो हमारा ऑब्जेक्टिव क्या हुआ, जो हम लोग हाई डिस्चार्जेबिलिटी लेंगे उसको हम लोग ग्राउंड कलर में लेंगे, सो दैट हमारा वाइब्रेंट कलर आता है। तो इस ये एक इसका कंसेप्ट होता है। फिर अगर हम एलडी की बात करते हैं, तो एलडी को हम लोग हमेशा, जो जिसका लो डिस्चार्जेबिलिटी होता है, उसको हम लोग कहाँ यूज कर रहे होते हैं, उसको हम लोग यूज करते हैं इल्यूमिनेंट कलर में। इसको क्यों, इसको क्यों यूज करते हैं इल्यूमिनेंट में, क्योंकि जो भी इल्यूमिनेंट मतलब दैट इज वन इज विद द बैकवर्ड, जो सामने जो चीज आपकी आ रही होती है वो आपका ग्राउंड कलर ही बेस कलर हो रहा होता है। इसी को हम लोग बेस कलर कहते हैं, ग्राउंड कलर, बेस कलर। और इन द लो डिस्चार्जेबिलिटी उसको आप इल्यूमिनेंट कलर की तरह यूज करते हो। क्यों यूज करते हो इल्यूमिनेंट कलर की तरह, क्योंकि ये डिस्चार्ज पेंटिंग प्रोसेस में बहुत कम इफेक्ट हो रहा होता है। ये चीज आपके लिए बहुत ज्यादा समझना जरूरी है। और इसका मतलब क्या है कि एलडी जो डाई होती है, उसकी जो कलर इंटेंसिटी है और स्टेबिलिटी है, वो हमेशा बनी रहती है। इट ऑलवेज रिटेन्स इट्स कलर इंटेंसिटी एंड द स्टेबिलिटी even after the discharge printing process again and again. So it provides contrast and the depth in the final printed design, if we say about. So जो आपका ऑप्शन होगा, एच डी कैन बी यूज एज ग्राउंड कलर एंड एल डी कैन बी यूज एज illuminant कलर। ऑप्शन डी इज द करेक्ट ऑप्शन। So you I think you got this concept कि एच डी can be highly discharged and it is effective during the printing process, resulting in the creation of the more vibrant colors on the fabric. And in case of ld, it is used as illuminant color because it is less affected by the discharge printing process, maintaining its stability and color intensity, and it provides the contrast and the depth in the final printed design on the fabric as well. So I think ये चीज आपको थोड़ी सी समझ में है। इसके लिए दो चीज जरूरी होती है, कि इसके लिए आपको थोड़ा सा कंसेप्ट का प्रॉपर अंडरस्टैंडिंग होना चाहिए। So I would suggest कि you must have got this answer. So option D is the correct answer. So the next question says that a fluorocarbon based soil release finish consists of an alternating hydrophobic blocks and hydrophilic blocks arranged side by side on the fabric surface. And the correct statements amongst the following is are. Option 1 says that in dry state the hydrophobic blocks shield shield in hydrophilic dry state, the hydrophilic blocks shield the hydrophilic blocks to repel the soil. And during washing the hydrophobic blocks swell and facilitate the release of the soil. So option C says that in dry state hydrophilic blocks shield the hydrophobic blocks to repel soil. And option D says that during washing the hydrophobic blocks swells and release the soil. So इसमें आप देख ही सकते हो, if you say कि a fluorocarbon based soil release, what is soil release finish? The one thing is soil release finish. So if I talk about the soil release finish, so you should know ki what actually is soil. The finishes that are used for the removal of the soils, and which type of finishes are used for the removal of the soil. Hydrophobic fibers generally have need these soil release finishing process. Example, if I talk about polyester, so polyester have require this soil release finishing process. Hydrophobic means water repellent, मतलब water one is water absorbent or water repellent. If I talk about whose moisture hydrophobic fibers have greater tendency for soil release, so these fibers attract soils. So example, polyester. Why polyester? Because its moisture regain is least, 0.4% moisture regain it has. Moisture regain. So if I say about the fluorocarbon based fluorocarbon based, so these are basically used for these soil process, soil repellent process. Why these are basically used? Because there is a reason for this process, because these fluorocarbons uh, are negatively charged, and these if you have read chemistry, so the property of the fluorocarbons is highest for the removal of the soil, and for water repellency these based are used. And so if I take about these things in this, what happens is hydrophobic blocks. One is, these are block structures. One is hydrophobic and hydrophilic blocks. This is surface. Suppose this is a surface. In this, you are treating this fluorocarbon base. So hydrophilic and hydrophobic and hydrophilic. These two blocks are arranged alternatively on the surface. So if I uh, consider two states, one is a dry state. So in this dry state, what happens is, in the dry state, what hydrophobic block acts as a shield. If the fabric is dry, so hydrophobic blocks acts as shield. Why it acts as shield? Because there is no water present. Water is absent in dry state. Dry state contains no water, so it acts as shield. But in the wet state, what happens is, wet state means H2O, H plus ions and OH minus ions are present, and these attract onto the fabric surface. So in hydrophobic, due to the absence of water, it prevents the soil from adhering to the fabric by repelling water and soil particles. So in dry state, these hydrophobic blocks act as shield, and shield the hydrophilic to repel the soil. Hydrophilic blocks. So this option is correct. So it says this is a MSQ type of question. So here one or more than one question is correct option. Or if I consider second options, ki, what happens in the washing process. So if I say these, in during the washing, the hydrophilic blocks swell and facilitate the release of the soil. So during washing, why washing means water is present and you are putting water. So these hydrophilic means water is present, so these are hydrophobic and hydrophilic blocks. So what happens in washing, so hydrophilic blocks swell when they come in contact with the water and the detergent. Detergents are also used along with the water, so they swell this, and this facilitate the release of the soil. So these are the mechanism how the soil is released. So option A and B is correct. So option C is wrong, because hydrophilic repel the soil. In the hydrophilic block shield the hydrophobic blocks, whereas hydrophobic shields the hydrophilic. So these are two different mechanisms. You should clearly understand. If you read in detail about the fluorocarbon based soil release finishes, we have discussed and we will be discussing these in detail in the courses segment when we discuss each and every points. So I would recommend to join the full courses as well, and do subscribe to this channel as well. It will help you to grow in this segment, and it will enhance your studies also. So we are there to help, and I think this must be clear. And during washing the hydrophilic ball block, these two options are automatically wrong. So just apart from the gate 2024, how you attempt the paper is also becomes important as far as your gate examination is concerned. So you can see there can be only two options. One is A or B. Matlab, if I say in these two only one is correct, in these two only one is correct. So this is the type of where gate is always asking. Now coming to the next question, it says that, I hope these things must be clear to you. So now coming to the next question, it says that this is a numerical based question, and it says that 1 kg bone dry cotton fabric is padded with water to obtain 80% wet pickup. So if I say about this segment, So the temperature of the wet fabric after padding is 30 degrees Celsius. Assume the specific heat of water to be 1 calorie per gram degree Celsius. The latent heat of evaporation of water to be 540 calorie per gram, and the specific heat of cotton to be zero point 0.3 calorie per gram degree Celsius. The energy in kilocalorie required to dry the fabric completely in integer is. So now, uh, for this you should have this basic understanding about the chemistry, textile chemistry, and also the basic chemistry of evaporation, where we read a specific latent heat of evaporation and a specific heat of evaporation of water and latent heat of evaporation of water. So this you must have read in the basics in class 11th and 12th also. Key, consider, suppose we consider weight of fabric, if we consider 1 kg, 1 kg we have considered the weight. So because it is given as this 1 kg, and wet pickup is 80%. Wet pickup means the amount of the water that is absorbed on the cotton, on the fabric after the padding. So this is the basic meaning. If the fabric weight is 1 kg, so what would be the weight of the water? Weight of water, if I take about, so water would be 80% of 1 kg. So it is 0.8 kg, or 800 gram of water is present. I think this must be clear ki, for this. And now what we have to do? This is padded. The temperature of the wet fabric after the padding is what process? You pass on to this rollers after this, so that you pass the fabric onto this rollers, so that it absorbs the water, and after that you take it out. Assume that the specific heat of water is 1 calorie per gram per day. The latent heat of evaporation of water to be 540 calorie per gram, and the specific heat of cotton to be zero point 0.3. The energy in kilocalorie required to dry the fabric completely in integer is. So we need to increase the fabric from 30 degrees Celsius to 100 degrees Celsius. And then we need to evaporate this. So from 30 to 100, yeah, there is an increase of temperature increase. Whenever there is an increase of temperature, you know that specific heat of evaporation of specific heat of evaporation is there in case of when the temperature is increased, or when this state is increased, because here it is water, and when it would be evaporated it will convert into vapor. So here state change, state change, and here only temperature change is there. So whenever there is a state change, what happens is you apply the latent heat of evaporation. It is ml. Or whenever there is a temperature change, you apply mc delta t. mc delta t. So these are two things. Now let's just check. So from 30 degrees Celsius to 100 degrees Celsius. So here what will happen? Ki specific heat of evaporation, specific heat of evaporation of water is mc delta t. mc delta t. Here we are talking about water only. So water is how much water is there? 800 gram. We have already taken the scene. So 800 we are keeping it in gram, and this is given as C is given as what? C is a specific heat of water is 1 calorie per gram degree Celsius. So we need to take care of the units as well. So 1 calorie per gram per degree Celsius, and temperature delta T is temperature difference. So 100 minus 30. If you calculate, so 800 into 70, 56,000 calorie. So 56,000 calorie आया. And if we calorie into kilocalorie, if we talk about, so 56 kilocalorie. This is the thing. And when water is temperature you are also increasing, but it is on the fabric. The weight of the water is on the fabric because you have already padded. So we need to check that of the wet cotton fabric also. Wet cotton fabric water will be increased, and that of the evaporation of the wet cotton fabric will need to be also increased. So a specific heat of evaporation of wet cotton fabric is how much? Mc delta T. Wet cotton fabric means not only water but the cotton fabric as well. So combining both these things. So what is the wet cotton fabric weight was how much? 1 kg. So 1 kg is 1000 gram. And what is the kilocalorie? Specific heat of cotton. The cotton is in wet state. So 1 kg of bone dry cotton. So bone dry cotton, matlab not wet cotton. So it is only cotton. A specific heat of evaporation of cotton fabric. So 1000 into C is a point 0.3 into, if I talk about this segment, into delta T is how much? 100 minus 30. So if I consider all these statements, you will see 17 to point 0.3 is 21,000 calorie. So 21,000 calorie. It will come out to be 21 kilocalorie. This is this and this is this. Now this we have talked about the temperature change. This is about the temperature change only. And when we talk about the state change, state will also be changed when we increase the temperature from 100 degrees Celsius to 100 degrees Celsius into water, into 100 degrees Celsius into vapor, if I talk about, because we have to evaporate. So when we consider this vapor segment, so what will happen? The latent heat of evaporation of water, now we need to compare. तो ये हो गया state change. Latent heat of evaporation of water is ml. Ml means 800 into what is the latent heat given? 540 calorie per gram. Latent heat of evaporation of water is given as 540 calorie per gram. So 800 means water will already be evaporated. So 800 into 540, it will come out to be, just calculate this segment. It will come out to be 54 into 8 is 432. 432,000 calorie. It will come out to be 432 kilocalorie. Now the you need to consider what you need to calculate: the total energy required to dry the fabric completely in integers. So total energy required, total energy required to dry the fabric is how much? 56 plus 21 plus 432. When you will sum up all these things, it will come out to be 509 kilocalorie. So this would be the final answer, and you need to write this in answer numerical answer type only. So I hope this type of things must be clear to you, and you must have got the basic idea how these things actually works, and what is the thing that you need to consider on this aspect, if I talk about in general. So just revising this segment on all these things in a very quick manner, just to summarize the concept to you in the manner exactly what happens. And these type of questions are basically a mix of your textiles and the basic physics that we read in our academics. So whenever there is a temperature change, there is a mc delta t you need to apply, and when there is a state change, you need to apply the ml. So you need to convert 30 to 100 in the same state. So only the temperature is changed, and once you increase the temperature of the water, and then that of the cotton fabric also. So when you will increase the temperature of the cotton, so this one is taken as the cotton fabric, and the second one for the water. And secondly, when you increase the temperature from one state to another state, it will come out to be ml. And when you will sum up all these things, this will be compared, and all these things you can see in this segment. So this is how these questions are done. Now coming to the next question, that says that a print paste for pigment printing of cotton is prepared by using a synthetic thickener. The suitable chemical amongst the following to build the viscosity of the print paste is the if I talk about this is a very direct theoretical question. Print paste for pigment printing. What is pigment printing? If I tell about pigment printing, is basically what happens is in the pigment printing, pigments basically don't have the affinity for the fiber. They are used along with some other compounds. So that is a binder. If I tell about, so pigments are used along with the binders because they don't have any uh, affinity of their own. So these are prepared using the synthetic thickener. So the suitable chemical among is the following to build the viscosity of the print paste is. So pigment printing is used using a synthetic thickener. Synthetic thickener can be any one. So in pigment printing of the cotton, what happens is, if you have read, then ammonium hydroxide is used for this pigment process, and it is also used as a thickening agent also. Thickener, the role of the thickener is it helps to build the viscosity, because viscosity means viscous, how much viscous. If the only difference between the printing and the dyeing is key here, you need to showcase the print, showcase your prints. And in case of the dyeing, you dye in this segment, and printing once done, it cannot be overcome. So that's why you know that printing is a very difficult task, and the major great printers are very highly paid. Because every in the entire if you start from the spinning, every fault can be rectified, and even dyeing can be rectified in other aspects. Spinning can be rectified in the dyeing process. Matlab, every faults are overcome, but once the printing is done, it can't be overcome. Printing once done is always done. So there is no scope for error for the printers, print masters. So here the each and every components become important, and to maintain the viscosity is also important. Ammonium hydroxide being basic in nature, NH4OH are used for this pigment printing. So, and it is also used as a thickening agent to build the print paste formulations. So formulations are important for you, formulations, and it also helps to maintain the built viscosity, print viscosity. So option B is the correct option, NH4OH. So this is this thing. Now just coming to this another question. It's it says that what happens is ki, if I tell about this thing. So if you read this segment, so what happens is surfactant. Consider the following diagram. When an oil droplet is formed on a fabric immersed in water, at equilibrium, the balance of the various interfacial forces acting on the droplet is given by the following equation. Gamma Fw is equal to gamma Fo and plus Ow cos theta. So when a surfactant added to the water, assuming that the Gamma OW and gamma FO remains unchanged. The following happens. FW decreases and the oil droplets becomes rounder. FW increases and the oil droplets tends to be flatter. This decreases and the oil droplets become flatter and the oil droplets becomes rounder. So just to give you a glimpse of all these types of questions, this was a 2 mark question. If I say ki this is not up to the standard, you see this question to be very hectic, and you are seeing these equations and the diagram and these gamma and all these things. This all things are just to confuse you. And if you know the concept very carefully, the concept of surfactant. What is the surfactant? Surfactant means surface active agents. It is due to the surface tension. Surface tension and the water droplets. The surface tension is the phenomena of the matlab sir, when the surfactant is added, the surface tension becomes lower, and the tendency of the water droplet changes due to the surfactant. And you just need to know the tendency of the this surface. Suppose this is a fabric, this is the fabric, and this is oil droplet. Oil is oil in water. When a oil droplet on the fabric immersed in water, matlab oil and oil and water droplet are there. So this droplet is put onto the fabric. So what will happen? It will either absorb onto the fabric, because oil have no tendency for absorption. So if it will absorb or it will not absorb, you need to check this aspect. And the angle that will form with the surface is known as gamma. Gamma FO means angle of fabric with respect to oil. Angle at the fabric oil interface, we say this as interface. Interface means this is the angle that the fabric is making with the oil. So this is gamma FO, fabric oil interface. So this is how these things are done and are seen. So if I say about all other aspect, so you need to see this aspect also, ki in this gamma FO and gamma FW, fabric water interface and oil water interface. So these are three different types of interfaces that are present. So when a surfactant is added, so to the water, its surface tension decreases. Means suppose a water droplet is there, so surface tension is there. Surface tension is there. Due to surface tension, it will absorb this. And when in this area, so the oil, the water droplet is completely rounded. Why rounded? Because the surface tension is completely balanced in all these things. But the role of the surfactant is to decrease the surface tension. And when it decreases the surface tension, so the structure of this becomes rounder. So the oil droplets becomes round in shape. So this becomes rounder in shape. So oil droplets is rounder in shape, and the surface tension decreases. Which at which surface? Surface is what? Fabric water interface. Because when it will absorb, the surface tension in the fabric and oil, not oil, but at the water interfacing, it decreases, because the role of the surfactant is only to decrease the surface tension. So gamma FW decreases. If I say gamma FW decreases, and the droplet oil droplet becomes round. So while which option is correct in this option? So option A is correct. So this is how these things are done, if we see about all these aspects. So I hope this must be clear to you. Now coming to the next question, it says that this question says that amongst the following given options, the condition which will increase the equilibrium wicking height of the contact, wicking height of the water in a yarn is or. higher contact angle between the fiber and the water, lower contact angle between the fiber and water, higher capillary diameter and lower capillary diameter. So you need to see that which is due to the contact angle. Contact angle is the angle that the suppose if I say this is a fabric surface, and when the water droplet is put into this, when it is seen with the angle, so at this angle, if suppose this is completely hydrophobic, so the angle that it makes with the fabric surface is known as the contact angle. So if it is hydrophobic, hydrophobic means it will not absorb the water, the angle is obtuse angle. Obtuse angle means greater than 90-degree angle contact angle is formed when it is hydrophobic fibers. For hydrophilic fibers, the angle is acute angle that is formed because the fab this is absorbed by this surface, and this angle theta is less than 90-degree, if I say about so it is hydrophilic. And in special cases that the where it is super hydrophobic fiber, super hydrophobic super hydrophobic fibers, where theta is greater than 150-degree. So these are super hydrophobic. The example of this is lotus. Lotus leaf is one of the such example of the super hydrophobic fibers. So equilibrium wicking height of the cotton in the yarn is done when there is lower water contact angle between the fiber and the water. It helps to increase the wicking height by improving the wetting ability, if I say about. So lower contact angle between the fiber and the water is required in order to increase the wicking height of the cotton in the yarn. So this is lower contact angle. And the another one is diameter is also should also be less. The capillary diameter is this diameter. This is the capillary, if I say about the diameter, the capillary should also be less, so that the equilibrium wicking height of the cotton water in the yarn. So wicking height means this is considered the wicking height. So if I say the diameter should also be lower, so lower capillary diameter and lower contact angle between the fiber and the water, these two options are correct. And this is the MSQ type of question. So in the paper, you there would be options where you can see which type of questions are MSQ based, and which type of questions are MCQ based. So you can clarify them accordingly, and there would be no confusion at all for this aspect. So now let's look on to the another question that says that consider the following equilibrium dyeing isotherm for dyeing of polyester with dispersed dye at 100 degree Celsius and 120 degree Celsius. Among us the following, the correct options, the correct statement is oblique R. So when we say about the polyester and the dispersed dye, so when we discuss about the isotherm concept, so you must have read about the isotherm concept ki isotherm for the adsorption of the dispersed dye on the hydrophobic fibers, that is polyester. So for polyester, there is a equation for the Nast isotherm. Nast isotherm is at the DF and DS, dye in fiber and dye in solution, if I talk about. So this is a straight line curve. This is the isotherm that is formed is Nast isotherm, that is formed between this polyester and dispersed dye. These questions are also asked for this aspect. And also one isotherm is Langmuir isotherm. You should also remember this Langmuir isotherm. So in this Langmuir isotherm, what happens is amount of the dye adsorbed increases with the increase in the dye concentration up to the certain point, and it is generally used for nylon and acid dye, if I say about these acid dyes. So Langmuir isotherm is this. If use need to, so df is equal to k times ds. This is the equation for the Nast isotherm. And for Langmuir isotherm, what is the equation? Langmuir isotherm, the suitable fiber, and the dye is nylon acid dye for Langmuir. And in Langmuir it says that df is equal to k times ds into d- into sf. These are all other aspects apart from this question, but this is in line with this segment. That's why I'm telling to you. We have you just enroll yourself if you want, so that it would be beneficial for you and your preparation aspects also. So just checking with this Langmuir concept. So this Langmuir says that Langmuir isotherm is it increases up to a certain point and then remains constant. So this is the dye in isotherm, and the Friendlyuk isotherm is for the cotton aspect. So if I say about this Friendlyuk isotherm is for this aspect. If you say that this increases up to this aspect, so this is a df and ds. So df is equal to k times ds ki power n. So this is for cotton and cellulosic. What is Friendlyuk isotherm? Friendlyk. Friendly isotherm. So these are three isotherms that you need to remember. So Nust isotherm is for dispersed dye and polyester. If you say that in this aspect, Nust isotherm, if this is temperature is higher, the rate of the dyeing is also higher at higher temperatures. So at 120 degrees Celsius, the rate of the dyeing is must be higher as compared to this aspect. So at 120 degrees Celsius, it is higher than 100 degrees Celsius. So saturation, if the dye in the fiber is high, so that is the dye uptake is higher at 120 degree Celsius. If you say about this aspect, so saturation dye uptake at 120 degrees Celsius is higher than at 100 degrees Celsius. And it also it says that the dye solubility, and as you increase the temperature, the dye solubility increases. It is directly proportional to the temperature. So that the dye solubility at 120 degrees Celsius is much more higher as compared to that of the 100 degrees Celsius. So it says that dye solubility at 120 degrees Celsius is higher than that 100 degrees Celsius. So option B and C are correct. So I hope this is you must have understood. The rate of solubility of the dye and the saturation dye uptake is higher at the higher temperature. So these things must be clear to you. Now coming to the next question, it says that among us the following, the properties of the dispersed dye that allows it to be applied on the polyester by the thermofixation method is R. So the property of the dispersed dye that allow in the thermofixation, matlab, how these thermofixation means you give the temperature at a fixed temperature rate around 200, 210, 180 to 200 degrees Celsius. You just increase the temperature, and it all depends upon the sublimation tendency. If you know the thermofixation methods, thermofixation, and so it depends upon the sublimation tendency. As whatever the dyes there are, if they can sublime and then penetrate into the polyester fibers, in this case especially when it would be subjected to a heat during this process, and what is the temperature range if we say 180 to 210 degrees Celsius. So in this temperature range, when it will have good sublimation properties, then it will be can be fixed onto this aspects, and it would result in the effective dyeing process. So this is the complete answer. So option A is the correct option if I say about. Now just looking into this question, it says that a cotton fabric is given crease resist finish with 60 gram per liter DMDHU aqueous solution by a continuous method. The density of the padding liquor is 1.1 gram per centimeter cube, and the wet pickup is 110 degrees Celsius. Assuming that the entire DMDHE on the fabric is consumed during the cross-linking reaction with the cellulose, the nitrogen percentage of the finished fabric is. So for this aspect, you need to know what is a DMDHU and how it is used, why it is used, DMDHU. So if you know What is DMDHU? It is dimethylol dihydroxy polyurethane hydroxy ethylene urea. So this is basically the DMDHU. So if you know about this DMDHU, if I say so, in this aspect, what happens is, suppose we consider the weight of the fabric as given as 181 kg, and it says that the wet pickup is 110%. When wet pickup is 110% means how much the how much liquor is used in the dye bath is how much. So wet pickup is 110% means 110 upon 100 into 1 kg. So it is 1.1 kg liquor in the dye bath, in dye bath. You need to solve this in a sequence wise manner, and the density is given as 1.1 gram per cc, means in 1.1 gram 1.1 gram per cc centimeter cube. So 1 point in 1 centimeter cube. So for 1 kg it would be 1 liter. The density is given as this. So it says that in 1 kg DMDHU, how much DMDHU is basically the crease resist finish that is applied onto this fabric. So for 1 kg of the fabric, 60 gram DMDHU is used. 1 kg fabric, 60 gram finish is required. DMDHU is a finish, kind of finish. This is required, DMDHU. And you know that we need to see how much DMDH use in 1 kg. 60 gram is required, so 1 kg fabric, so how much DMDHU is required, and then nitrogen percentage we need to find it out. And in 1 DMDHU, if you see the structure of the DMDHU, so 1 DMDHU contains 2 nitrogen units. So 2 nitrogen means 28 gram. 1 nitrogen is, and 2 1 nitrogen is 14 grams. So 28 gram nitrogen is there in 1 DMDHU. 1 DMDHU has 28 gram nitrogen, means 178 gram DMDHU contains 28 gram nitrogen. So 1 gram DMDHU has 28 upon 178 gram nitrogen. And how much DMDHU is given as 60 gram? 60 gram DMDHU is given. In 60 gram DMDHU, how much nitrogen would be present? 28 upon 178 into 60. Into 60 would be present. So this is the nitrogen, and you need to find the percentage of nitrogen in 1 kg fabric. So whenever you need to find this is the nitrogen content upon the fabric weight. If I say about this, is we are considering it in gram. So this is gram. 28 upon 178 into 60 gram nitrogen is present, and with respect to the fabric we need to find. So 1 kg fabric, so this is gram, and this is how much. 1 kg fabric means 1000 gram fabric ho gaya, and you need to find the it in percentage, then you will multiply by 100. So this you will solve, and when you will solve this aspect, so 2 times, and whenever you will solve this aspect, it will come out to be around 0.95 percentage. So this is the correct option. If you say about, so you need to consider 3 4 important points in this aspect. Key What is a DMDHU, and what is the function of DMDHU. So DMDHU basically is a crease finishing agent and a cross-linking agent. Is also used in with the cellulose. So DMDHU is a crease-resistant finish, and it is used along with the cotton fabric. So here, n- what if I summarize this in 1 2 aspects? It says that कि what happens is कि cotton fabric is used along with DMDHU and by a continuous method, and it is assumed that the entire DMDHU is consumed during the cross-linking reaction with the cellulose. Then nitrogen percentage content of the finished fabric is, if you need to find this aspect, so you need to find how much nitrogen is there in 1 DMDHU. 2 nitrogen is there, means 28 gram nitrogen. And how much DMDHU is there? 60 gram DMDHU is considered. So in 60 gram DMDHU, whatever is consumed on the fabric, you need to find that out. So in 178 gram, 28 gram nitrogen is required. So for 60 gram of DMDHU, how much nitrogen content would be required, that you need to find it out. And then you need to solve this accordingly. So when you have found in 60 gram nitrogen, in 60 gram nitrogen, 60 gram DMDHU, how much nitrogen is present? So 28, this is simple unitary method. So this is the nitrogen, and you need to percentage of the finished fabric with respect to the original. Matlab, this is the fabric, this is the fabric, and this is the finish you need applied. So when you need to find the percentage, so with respect to the fabric is 1 kg 1000 gram, and you need to find in percentage, the percentage is in 200. I hope these lectures would be clear to you. And this was all about this textile processing aspect. And I hope in this series, all gate 2024 textile chemistry questions were solved, and you must have got a basic idea of how all these things are actually working. If you find it useful, do like, share these efforts with your friends, and do subscribe to this channel, and also enroll into all these courses that are mentioned below. And you will get a basic idea, and you will get an entire understanding how the pattern is changing, how you need to focus on your studies, and what are the different aspects that is being changed, and that will be useful for your further examination aspects. So and in the upcoming lectures, we will see different aspects, starting from textile fibers, then spinning, then textile testing, then fabric manufacturing. One aspects in a day we will be taking in, and we will cover these aspects accordingly. So I hope you must have liked this lecture. Do if you have any doubts, you can ask in the comment box, and we will meet in the next lecture. Till then, keep learning, and thank you. So if you have any doubts, you can ask this section, and one is writing the concepts are unable to concept. So if you have any particular doubt in the particular question, you can ask in this aspects. And uh, these are the things, and Hassanji is writing about all these things. So if you are unable to get the particular question, you can ask, and I will try to get these aspects, but in Hindi, and the proper audience is unable to understand in the only Hindi. So it would be a mixed kind of Hindi and English both. So I hope this fits your doubt, and if you are unable to understand, this is your fault, and we can proceed further. And thank you.